We're starting to develop a list of rules for derivatives, and right now I want to look at what's called the product rule. Now, with the product rule, we're obviously trying to find the derivative of the product of two functions, so the derivative of f times g of x. So we start with our definition of the derivative, that limit as delta x approaches 0 of f times g of x plus delta x minus f times g of x all over delta x. Now, obviously, when it comes to f times g of x plus delta x, that means f of x plus delta x times g of x plus delta x. And the same thing for f times g of x. That's f of x times g of x. Now, I have split this up and put a big gap in between these two terms because I'm going to pull off this special little math trick. I'm going to not change the actual fraction at all because I'm going to subtract f of x plus delta x times g of x. And then I'll add f of x plus delta x times g of x. So I subtracted and added the same thing. They end up canceling each other out. But what this does is, looking at it in this way, allows me to rearrange this fraction a little bit. What I'm going to do is break this fraction up into two pieces. And on the front piece, I notice that my numerator has this common factor of f of x plus delta x. And on the second piece, there's a common factor of g of x. So for each of these two fractions that I'm going to make, I'm going to factor out those common factors. And we end up with something that looks like this. Notice I broke it up into two terms, my two fractions. And out of the first fraction, I took out that common factor of the f of x plus delta x. And in my second fraction, the second term, I took out that common factor of g of x right here. Now we're ready to actually take these limits. Right? We're going to let delta x approach 0. So what that means for us, as we go piece by piece throughout this expression, delta x is going to turn to 0. So this will leave us with just f of x. When we look at this fraction, g of x plus delta x minus g of x over delta x, that's our definition of the derivative. In the second term, we have g of x. There is no delta x in there, so we don't have to worry about that. And we have another fraction that should look familiar, and that's going to be the derivative of f of x. And that's how we get our product rule, that the derivative of f times g of x is going to be f of x times the derivative of g of x plus g of x times the derivative of f of x. If we look at that in terms of Newton's prime notation, that'd be f times g prime is going to be equal to f of x times g prime of x plus g of x times f prime of x. Now this, when you keep saying this over and over and over again, it really just kind of sounds like droning on, and it's hard to keep that straight. When I was in college, I had somebody tell me this, and it was very helpful. What they said to me was, the product rule is 1 d2 plus 2 d1. Meaning that when we're looking at the derivative of f times g, it's going to be f of x times derivative of the second function. So that d dx of the second function, g of x, plus the second function times derivative of the first function. And saying this might be more helpful in helping you to memorize and remember the product rule. So let's practice using it. We want to differentiate f of x equals x plus 3 times x minus 1. Now, obviously, we wouldn't use the product rule to do this because we could rewrite f of x as x squared plus 2x minus 3. Then finding the derivative of f of x is ridiculously easy. We use that power rule there, 2x. And then the derivative of 2x, the next term, is just going to be 2. But let's see if we can get that by using the product rule. So back to f of x being x plus 3 times x minus 1. Now when we want to find the derivative, we're going to remember 1d2 plus 2d1. So my 1 is my first function, the x plus 3. d2, so the derivative of x minus 1 is just 1. 1d2 plus 2d1. The 2 is the second function, the x minus 1, times the derivative of the first function. Again, 1. Now when we simplify this, what we're left with is x plus 3 plus x minus 1, which is that 2x plus 2 that we were hoping for. Let's try another one with g of x being 3x minus 2x squared times 5 plus 4x. Now when we want to find the derivative of g, 1d2 plus 2d1. So 1 is the 3x minus 2x squared. d2. Derivative of the second function is 4 plus 2d1. So the second function is 5 plus 4x. And the derivative of our second function is going to be 3 minus 4x. If we were to clean this up a little bit, I'd distribute the 4. And then multiply our binomials over here to give us what? 15 minus 20x plus 12x minus 16x squared. And we combine like terms, getting negative 24x squared. And then we will have plus 4x plus 15. Of course, we've been using the derivative in a few situations, one of them being finding the equation of the tangent line. We got the function k of x equals x e to the x at the point when x equals 2. So in order to write the equation of a line, we need a point and a slope. As far as the point goes, the x-coordinate is going to be 2, and the y-coordinate is going to be k of 2, which is just 2e squared. So we have our point, 2e squared. Next, we need to find the slope. And of course, the slope of a tangent line is the derivative, so I'm going to find the derivative function first using the product rule. Because we're multiplying x times e to the x, we're going to do 1d2, so x, and times the derivative of e to the x, which is e to the x, 1d2, plus 2d1, e to the x, times the derivative of the first function, which is just 1. All right, so we get a nice x e to the x plus e to the x. When we want the slope, at 2, we're just going to plug 2 in there, and we'll have 2e squared plus e squared. All right, now we have everything we need. Here's our slope, here's our point, so we can write it in point-slope form. Y minus the y-coordinate is equal to slope times x minus the x-coordinate. And there's our tangent line. We've also used the derivative to help us find instantaneous velocity. So if we're looking at a particle moving along the x-axis, so that its position after t seconds is given by p of t equals 2t times the cosine of t minus 2 sine of t. We want to find the particle's velocity at the instant when time is pi over 6 seconds. So we're going to need the derivative. We have two terms, and in our first term, we're going to have to use the product rule because we're taking 2t times the cosine of t. So 1 d2, and derivative of cosine is negative sine. 1 d2 plus 2 d1. So cosine times the derivative of 2t is just 2. As we move on to the second term, the derivative of negative 2 sine of t is negative 2 cosine of t. We can kind of clean this up a little bit. We got 2t or negative 2t sine of t plus 2 cosine and minus 2 cosine. So these two are going to cancel each other out, and our derivative is just the negative 2t sine of t. Now we can find that instantaneous velocity by finding the derivative at the instant that t is pi over 6. So we just plug that in. And we'll end up with negative 2 times the pi over 6. And the sine of pi over 6 is 1/2. So our instantaneous velocity will be negative pi over 6. And our units would be units per second.